We first created a model of a gear using a CAD software and then chose the settings we wanted on the computer. We then sent the file to the 3D printer to be printed layer by layer. The first step of water jetting the gear was to create a path file for the machine to follow. We then found some scrap steel, clamped it into the water jet, and calibrated the Z-height. The machine then cut out the outline of the gear with the exception of one tab to ensure that the part doesn't come loose and fall into the water. We then grinded this tab off to create the final shape of the gear. For laser cutting, we used the same path file and loaded it into the Trotec software. We then calibrated the machine for the specific focal length of the lens. The laser then follows the outline of the gear, and we continue to repeat more passes until the laser goes all the way through the wood to separate our part from scrap.
In vacuum forming, the plastic sheet is heated for 1 minute until proper elasticity. The sheet is then dropped over the part and a vacuum sucks out the air to form the sheet around the gear. After cooling, the plastic mold is ready to be used. Epoxy is then poured into the mold and takes 16 hours to cure.
We then wanted to create something to show how these four materials would interact with each other. We created a simple box that houses the gears and allows the user to turn the first gear and subsequently turn the rest.
Disclaimer: no razors without the removal of the lubricating blade were used in this process.